All right, let's continue in our quest of linear functions, chapter 5, section 6, parallel and perpendicular lines. So let's look at the slopes of two parallel lines. The slope 1, 2, 3 by 1, so the slope is 3 over 1, or 3. This line right here, 1, 2, 3, and it runs 1, so the slope of this line is also 3 over 1, or 3. Interesting. On this line right here, our slope is 0 on this horizontal line, and a vertical line, the slope, actually, we would say the slope is undefined on that one. So I'll have to take a look at those. So parallel lines, they have the same slope, because as the two lines move along, they will never intersect, so they should slope the same. So keep that in mind. And perpendicular lines, the example we saw was interesting because it was a horizontal and vertical line, so we want to look at a couple other lines that are not quite vertical and horizontal, but yet they are perpendicular, because two things need to happen with the slope. We need to see that they're the opposite and the reciprocal of it. So opposite meaning that the sign changes, and the reciprocal in the case that it flips. The slope flips. It's the opposite of what you see of the other one. So if that's the case, if my original slope is a over b, then my parallel slope should still be a over b. They should match. If my slope is -2, then the parallel slope should be -2. If my original slope is 2/3, then my parallel slope should be 2/3. If my original slope is 0, my parallel slope should indeed exactly be 0. Or maybe a snowman with a little hat. Let's keep going. So the perpendicular slope, remember two things need to happen. It needs to be the reciprocal and the opposite sign. So I'm looking back at my original here. If my original slope is a over b, I want the reciprocal, so b over a, and then I want it to be the opposite, which will be the negative version of it. My perpendicular slope of -2 is going to be 1 over 2, and the positive version of that one. If my original slope is positive 2/3, my perpendicular slope will be the negative version of it and the reciprocal, which is 3 over 2. Now the 0 is always funky, because if my slope is 0, the perpendicular version of that will actually be undefined. Let's try it out on this one. Check whether two lines are parallel, perpendicular, or neither. So in order to make this happen, we need to identify the slope. So I'm going to get this in slope-intercept form. So y equals -1/5 x plus 2/5. Okay, so I see my slope on that one. Let's see if we can find it over here. I'm going to add 2x to both sides. -2/10 x, which is -1/5 x. So I'm going to look and I'm going to see that my slope is -1/5. I see my slope is -1/5. If they have the same slope, then they are indeed parallel. Let's try another one. Okay. 2x plus 6y equals a -3, and -3x plus y equals -8. Let's see what we can do here. Divide by 6, so I end up in my -2/6x minus 3/6. I'm going to look at this a little differently. So -1/3 x minus 1/2. Found my slope. Let's see if we can find it. Work it out on this other one. Plus 3x plus 3x equals 3x minus 8. Oh, that was nice. That's done. So my slope here is -1/3. My slope is 3. The relationship between these two is they are reciprocals of each other and they're opposite signs. This would make them perpendicular. So perpendicular's got those two characteristics. Ooh, I want you to try it. Here's two equations where you work them out, find their slopes on each one to help you see if they are parallel, perpendicular, or neither. Press pause. Pause, pause, pause. All right, they are close. It's -1/2 is the slope for this one, and this guy right here is +1/2. So not the reciprocal, but is the opposite sign, so it is neither. They will intersect and have a solution, but they're not parallel. Write an equation of a parallel or perpendicular line. So we have a point, and we know an equation that it is parallel to. All right, in this situation, we're looking to see that it is parallel. So if it is parallel, we know the slope. And if we know the slope and we know a point, we can use the point slope form. Let's use that. Okay, so that looks like this. So this is saying y minus the y point I have equals my slope, which is 3/5, times x minus the x point I have. Oh yeah, point slope form. I'm liking this. All right, let's keep working this out. So y minus 1 equals 3/5 x minus, this is 3/5 times 5, so it's 15/5, which is y minus 1 equals 3/5 x minus 3. I'm going to add 1, and I get myself an equation of a line that is parallel to this one. They have matching slopes. They are indeed parallel. All right, your turn. Give it a try. You're gonna it's also parallel, so keep an eye on its slope. And oh look, I gave you a point. I'd consider using the point. Yeah, point slope form. Press pause. Here we go. Same matching slope. So we know these are parallel. And I use my form here. Good stuff. Let's keep going. Write an equation of a parallel perpendicular line, okay? And we know this one is perpendicular, and I'm given a point, but okay, so if it's going to be perpendicular, if my slope is going to be perpendicular, it's going to be the reciprocal, so it's 4/3, and it's going to be the opposite. So I know what my slope is, and I know a point, so I'm thinking point slope form. What do you think? I'm feeling crazy. Let's try it. So 1 minus 8 that I know, or y minus the 8 I know, equals my slope that I know times x minus 1, y minus 8, distribute this, and plus 4/3. Let's get some 8 around. Y equals, there's the reciprocal slope that I'm looking for. And I have 4/3 plus 8. I guess you can say that is 8 4/3. We probably would turn that into a mixed number or something like that, but that'll work right now. Look at that. There's my reciprocal slope. Fantastic. Yes, you get to try it. Press pause. See if you can come up with a line that's perpendicular. All right, if these are going to be perpendicular, then I needed to use the reciprocal on the opposite slope, -1/5. I used my point slope form, plugged it all the way in, and I found my equation. Y equals -1/5 x minus 9/5. Let's do a little bit of a summary here with slope and parallel lines. So non-vertical lines are parallel if they have the same slope and different y-intercepts. Vertical lines are parallel if they have different x-intercepts. So an example would be if they have these two equations, same slope, they are parallel. In this case, if two non-vertical lines are perpendicular, if the product of their slope is -1, so product of their slope is -1, basically it's saying it's the opposite reciprocal. Like in this case, the opposite reciprocal of 1/2 is -2. If that's the case, then they are indeed perpendicular. Excellent. Well, I'm going to go see if I can burp the Fibonacci sequence.